Have you ever wondered how tiny computer chips, even from different manufacturers, manage to chat with each other seamlessly, sharing crucial information without getting tangled up? In I2C communication, the master-slave concept describes the fundamental roles devices play to organize this data exchange. It is a clear, hierarchical approach that ensures every piece of information knows exactly where to go and when. The core mechanism behind this efficient communication relies on two wires: a serial data line, often called SDA, and a serial clock line, known as SCL. The master device is the orchestrator here. It generates the clock signal that synchronizes all data transfers on the bus. More than just the clock, the master is also responsible for initiating all communication. It decides which specific slave device on the bus it wants to talk to by sending out a unique 7-bit address. Imagine it like a conductor calling out a specific musician's name before they play. The slave devices on the I2C bus constantly listen for their own address. When a slave hears its address called by the master, it then responds. The key takeaway here is that slaves never initiate communication themselves. They only respond when addressed by the master, preventing any data collisions and maintaining order. A neat insider detail is that I2C also supports multiple masters on the same bus. When this happens, a process called arbitration determines which master gains control, typically based on which master pulls the data line low first. There is also something called clock stretching, where a slow slave can temporarily hold the clock low to request more time. Practically, in an embedded system, a microcontroller often assumes the role of the master because it needs to control various peripherals. Sensors, EEPROM memory chips, and liquid crystal displays are common examples of slave devices that simply wait for commands or requests from the master. Understanding the master-slave relationship in I2C provides a clear, efficient, and robust method for your embedded devices to interact. It transforms what could be a chaotic mess of data into a well-orchestrated conversation, ensuring reliable system operation and data integrity for all your projects.